According to NFPA 13, standard for the installation of sprinkler systems, an automatic sprinkler system is required in meat processing facilities that exceed certain area and height thresholds. Specifically, if the area of the facility exceeds 12,000 square feet, or approximately 1115 square meters, a sprinkler system is generally required. Height is another factor. A sprinkler system is typically mandated if the building height exceeds 24 feet, which is about 7.3 meters. However, the 24-foot limit usually applies to lower floors. The ceiling height limit increases to 55 feet, or about 16.8 meters for upper floors. Considering a facility of 23,000 square feet with a 25-foot ceiling, the square footage exceeds the 12,000 square feet threshold, thus triggering the sprinkler system requirement under NFPA 13. The ceiling height of 25 feet, while above the 24-foot lower floor threshold, does not exceed the 55-foot limit for upper floors, so height is not a determining factor in this instance. If NFPA 13 mandates a sprinkler system, there are typically two primary options. Firstly, install a sprinkler system, and secondly, explore exemptions. Installing a sprinkler system represents a notable capital expenditure, but it ensures adequate fire protection for the facility. Alternatively, there may exist specific exemptions or alternative fire protection measures applicable to the facility. To explore potential exemptions, consulting with a fire protection engineer or the local fire department is crucial. As next steps, contacting the local fire department to request a formal inspection and guidance regarding the specific building should be done. They can provide clarity on the precise requirements based on local codes and NFPA standards. In addition, consult with a fire protection engineer. An engineer can conduct a technical assessment and assist in identifying potential exemptions or alternative fire protection options. Also, review local building codes. Review the specific building codes in the local jurisdiction to ascertain sprinkler system requirements. Fire protection requirements can vary based on the specific use of the facility, the occupancy type, and the specific stipulations of local codes. Therefore, consulting with relevant authorities is critical to obtain the most current and accurate information for the building and its intended use. In summary, firstly, confirm the square footage and ceiling height of the facility and compare them to the thresholds established in NFPA 13. Secondly, determine whether the local building codes align with NFPA 13 or if they impose more stringent requirements. Thirdly, consult with the local fire department and a fire protection engineer to obtain tailored guidance for the specific scenario. NFPA 13 provides comprehensive guidelines for the design and installation of automatic sprinkler systems. These systems are intended to suppress or extinguish fires, thereby protecting lives and property. The standard covers a wide range of topics, including system components, design criteria, installation practices, and inspection, testing, and maintenance requirements. The design of a sprinkler system is a complex process that requires careful consideration of various factors, such as the occupancy classification, building construction, and water supply characteristics. NFPA 13 specifies different hazard classifications based on the fire loading and potential fire growth rate of the occupancy. These classifications include light hazard, ordinary hazard, and extra hazard. Each hazard classification has specific design criteria, such as the sprinkler density, which is the amount of water discharged per unit area, and the sprinkler spacing. The building construction also affects the design of the sprinkler system. For example, the presence of concealed spaces, such as attics and suspended ceilings, may require additional sprinklers to protect these areas. The water supply must be adequate to meet the demand of the sprinkler system. NFPA 13 specifies the minimum water supply requirements based on the hazard classification and the design area. The water supply must be reliable and capable of delivering the required flow and pressure for the duration of the fire. The installation of a sprinkler system must be performed by qualified contractors who are familiar with NFPA 13 and local building codes. The installation must be done in accordance with the approved design and the manufacturer's instructions. The sprinkler system must be inspected and tested after installation to verify that it is functioning properly. NFPA 13 also includes requirements for the inspection, testing, and maintenance of sprinkler systems. These requirements are intended to ensure that the system remains in good working order and is capable of performing its intended function. Sprinkler systems should be inspected regularly to check for any signs of damage or corrosion. Sprinklers should be tested periodically to verify that they are operating properly. The water supply should be tested to ensure that it meets the minimum requirement. NFPA 13 is a complex and comprehensive standard that provides detailed guidance for the design, installation, and maintenance of automatic sprinkler systems. Compliance with NFPA 13 is essential to ensure that sprinkler systems are effective in protecting lives and property from fire. NFPA 13, the standard for the installation of sprinkler systems, is a widely adopted and referenced document in the field of fire protection. It provides comprehensive guidelines for the design, installation, inspection, testing, and maintenance of automatic sprinkler systems. While the standard itself does not have the force of law, it is often adopted by reference into building codes and regulations at the local, state, and national levels. As such, compliance with NFPA 13 is frequently a legal requirement for many types of buildings and occupancies. The specific requirements for sprinkler systems can vary depending on the jurisdiction and the occupancy classification of the building. However, NFPA 13 generally requires sprinkler systems in buildings that exceed certain size thresholds, have high occupant loads, or contain hazardous materials. In addition to the prescriptive requirements of NFPA 13, the standard also allows for performance-based design approaches. Performance-based design allows for the use of alternative fire protection strategies that achieve the same level of safety as a prescriptive sprinkler system. However, performance-based designs must be approved by the authority having jurisdiction, and they typically require a higher level of engineering analysis and documentation. The goal of NFPA 13 is to provide a reasonable level of fire safety for building occupants and to protect property from fire damage. Sprinkler systems are an effective means of achieving this goal, and they have been credited with saving countless lives and preventing billions of dollars in property losses. NFPA 13 is a continuously evolving standard that is updated on a regular basis to reflect the latest research and best practices in fire protection. The current edition of NFPA 13 is the 2022 edition, and it includes a number of significant changes from previous editions. One of the most significant changes in the 2022 edition of NFPA 13 is the adoption of a new risk-based approach to sprinkler system design. This approach allows for the design of sprinkler systems that are tailored to the specific hazards and risks of the occupancy. Another significant change in the 2022 edition of NFPA 13 is the introduction of new requirements for the protection of storage occupancies. These requirements are intended to address the unique fire hazards associated with storage occupancies, such as high-piled storage and rack storage. The NFPA develops and publishes more than 300 consensus codes and standards intended to minimize the possibility and effects of fire and other hazards. NFPA codes and standards, administered by more than 250 technical committees comprising approximately 8,000 volunteers, are adopted and used throughout the world. A key element of these codes and standards is that they are consensus documents, meaning that they are developed through a process that involves input from a wide range of stakeholders, including manufacturers, users, regulators, and the public. This consensus process ensures that NFPA codes and standards are technically sound, practical, and widely accepted. NFPA codes and standards cover a wide range of topics, including fire protection, electrical safety, building construction, and life safety. Some of the most widely used NFPA codes and standards include NFPA 13, Standard for the Installation of Sprinkler Systems, NFPA 70, National Electrical Code, NFPA 101, Life Safety Code, and NFPA 25, Standard for the Inspection, Testing, and Maintenance of Water-Based Fire Protection Systems. NFPA codes and standards are used by a wide range of stakeholders, including architects, engineers, contractors, building owners, fire officials, and insurance companies. These stakeholders use NFPA codes and standards to ensure that buildings and facilities are designed, constructed, and maintained in a safe manner. NFPA codes and standards are also used by regulators to develop and enforce building codes and regulations. The NFPA also provides a wide range of educational resources, including training courses, publications, and online tools. These resources are designed to help stakeholders understand and comply with NFPA codes and standards. The NFPA is a valuable resource for anyone involved in fire protection, electrical safety, building construction, or life safety. Its codes and standards are widely used and respected, and its educational resources are invaluable for helping stakeholders understand and comply with these codes and standards. Understanding the specific requirements for sprinkler systems involves considering various factors, including the building's occupancy classification, its size and height, and the local building codes and regulations. The occupancy classification of a building is a key factor in determining the sprinkler system requirements. Buildings are typically classified based on their intended use, such as residential, commercial, or industrial. Each occupancy classification has different fire hazards and risks, which are reflected in the sprinkler system requirements. For example, a high-hazard occupancy, such as a chemical plant, will typically require a more robust sprinkler system than a low-hazard occupancy, such as an office building. The size and height of a building also affect the sprinkler system requirements. Larger buildings typically require more extensive sprinkler systems to provide adequate fire protection. Taller buildings may also require special sprinkler system designs to address the challenges of water pressure and flow. Local building codes and regulations are another important factor to consider. These codes and regulations may adopt NFPA standards, or they may have their own specific requirements for sprinkler systems. It is important to consult with a local authority having jurisdiction to determine the specific sprinkler system requirements for a particular building. In addition to the prescriptive requirements of building codes and standards, performance-based design approaches can also be used. Performance-based design allows for the use of alternative fire protection strategies that achieve the same level of safety as a prescriptive sprinkler system. However, performance-based designs must be approved by the authority having jurisdiction, and they typically require a higher level of engineering analysis and documentation. When considering whether to install a sprinkler system, it is important to weigh the costs and benefits. Sprinkler systems can be a significant investment, but they can also save lives and prevent property damage. The costs of a sprinkler system include the initial installation costs, as well as the ongoing maintenance and inspection costs. The benefits of a sprinkler system include the reduced risk of fire-related injuries and fatalities, as well as the reduced risk of property damage. A fire protection engineer can help to evaluate the costs and benefits of a sprinkler system and to determine the best fire protection strategy for a particular building. A fire protection engineer is a qualified professional who specializes in the design, installation, and maintenance of fire protection systems. Fire protection engineers have the knowledge and experience to assess the fire hazards and risks of a building and to develop fire protection strategies that meet the applicable codes and standards. Fire protection engineers can also provide guidance on the selection of appropriate fire protection equipment, such as sprinklers, fire alarms, and fire extinguishers. The National Fire Protection Association offers a variety of resources to help building owners and managers understand and comply with sprinkler system requirements. These resources include NFPA codes and standards, training courses, and publications. The NFPA website also provides a wealth of information on fire protection topics. Sprinkler systems are an essential part of a comprehensive fire protection strategy. By understanding the requirements for sprinkler systems and consulting with qualified professionals, building owners and managers can help to ensure the safety of their buildings and occupants.